Hi, we're still working with the assessment and design of the physical environment, but today it's going to be in terms of the lighting and illumination. Lighting has a major effect on human beings. So, if we had poor lighting in a work environment, this could have a negative effect on the performance of workers, on their spirits and morale and safety, because poor lighting interferes directly with the tasks that workers are performing, because they need their vision in order to guide them while they are doing the activity or task at the work environment. Moreover, inadequate or poor lighting may cause workers to misread signs, make mistakes, and this would result in a lower productivity and reduced safety. In addition, poor lighting has a major impact on people's reaction to their working environment. So, for example, if you ask people to describe the place they work at, the building, the offices, how do they make them feel like? So, some people would say that this place looks dark and dingy or gloomy, or they would say it's depressing, awful colors, garish lighting. Garish is disturbingly flashy. So other people would say it's too bright or boring or too much white. Now, these are the negative comments that you might be hearing. Some positive comments would include it's bright and cheerful, it's clean, inviting, relaxing, and energizing. And this is what the source of the comments that you should be hearing from the workers in any work environment. There are several ways to improve the lighting conditions in addition to um, adding more light fixtures. This is the cheapest and the not that effective method. You can improve the lighting, okay, with better methods than just adding light fixtures. For example, maintenance of the light sources is at least as important. The well chosen paints and finishes on the ceilings, the walls, floors, the type of work surfaces, how do they reflect the light, is also very important. Some modification to the task itself to reduce visual demands is also a good way. So there are several ways to improve lighting conditions in any in-work environment. In any work environment, the light can come directly from the sun or from a light fixture. Also, light can arrive after reflecting off floors, walls, ceilings, and other surfaces. So, the amount of luminous energy falling on a surface is called illumination. It's measured in units of foot candles or lux. Lux is the SI unit of illuminance. It's equal to 1 lumen per square meter. Or you can say that 1 foot candle is equal to 10.76 lux. The illumination level of a certain surface depends on the intensity and the location of the available light source. The amount of light energy coming from a certain source and arriving at a certain surface decreases as the distance between the light source and the surface increases. So this is also related to the orientation of the surface with respect to the light source. When the light strikes any opaque surface, some of the light is absorbed by the surface and the rest is reflected away. The amount of the light reflected determines its brightness or luminance of this surface. Moreover, the amount of light reflected depends also on the color of the surface itself and its spectral properties. You need first to understand that we have two major types of reflection. We have the specular reflection and diffuse reflection. Specular refraction is defined as the light reflected from a smooth surface at a definite angle. So you can see that parallel rays all bounce off at the same angle. For example, the surface could be a mirror, it could be the surface of a lake. You can see the reflection, for example, when you see your face over someone else's eyeglasses. So this is a sort of specular reflection. So it depends on the smoothness of the surface that is reflecting, and this is what's called the spectral properties. While the diffuse reflection is produced by rough surfaces, they tend to reflect light in all directions. So when, for example, light is reflected off a mirror, then we will say that this surface, the mirror, is perfectly reflective. But when the reflection tends to be in almost every direction, we will call it as perfectly diffusing surface. These highly diffusing surfaces are often desirable because they reduce the unpleasant or harmful reflections or glare. White painted surfaces have a reflectance of around 90%. Newsprint, the paper used in printing, the newspapers, and bare concrete are around 50%. Dark painted surfaces may be as low as 5%. The use of appropriate paints and finishes is very important for spreading reflected light evenly across the workplace in a way that reduces the lighting bills and create a more pleasant working environment. So the industrial lighting recommend reflectance value of 80 to 90% for ceilings, 40% to 60% for walls, 25 to 45% for desks and bench tops, and 20% or higher for floors. Light in any work environment can be provided by different sources. We have the natural lighting that could be provided through windows and skylights is a very good and economical option. We have many different types of artificial lightings also used in work environments. So basically, methods of artificial lighting can be classified into 4 categories. The first method of the artificial lighting is the direct radiant, where 90% of the light is directed toward the object we want to view. And this is done by placing an incandescent or electric light or a fluorescent light fixture on the ceiling. And this is the most commonly used method in offices and many work settings. The second method is the indirect radiant. Here, instead of directing the light toward the viewed object, 90% of the light is directed upwards towards the ceiling. So the light reflected off the ceiling will illuminate the whole environment more uniformly than the direct lighting, and it eliminates the direct glare. But here you need to know that some light is lost because it's being absorbed by the ceiling. The third method is mixing between direct and indirect radiant. In this method, around 40% of the light is directed downward, while the rest is directed upward toward the ceiling. The fourth method is supplemental task lighting. Here we can put some lamps or other fixtures, but they will be located closely to the viewed object to provide a high level of light in a localized area. You can see that with the lamps put on the desks. Okay, it's localized to provide light directly over the desk. The light sources used for each of these methods can be incandescent bulbs, mercury lamps, fluorescent tubes, high pressure sodium lamps, low pressure sodium lamps, or metal halide lamps. Let's begin talking about the incandescent bulbs, which are inexpensive but the least energy efficient option, because these bulbs provide up to 20 lumens of light per watt of energy used and much lower levels for low wattage bulbs. These bulbs would burn out in less than a year and give off significant amounts of heat. While tungsten halogen filament bulbs last longer and are more efficient and provide a higher quality of light than the regular tungsten filament bulbs. The second type is the fluorescent tubes, which are 3 to 5 times more efficient than incandescent bulbs and have a much longer life. Now, the compact fluorescent lamps are available, which offer a cheap and highly efficient replacement for incandescent bulbs. Some modern fluorescent tubes provide light with an energy spectrum that closely matches that of a natural light and provide good color rendering. Now, what is color rendering? The color rendering of a light source indicates the ability of this light source to reproduce the real color of an object. Now, color rendering is given as an index between 0 and 100, where lower values indicate poor color rendering and higher values indicate a good color rendering. Now, these indices help designers determine how well colors, let's say colors of costumes, of sets or furniture, will look like when illuminated by a particular light. So, a color rendering index of 100 shows true colors of objects. You can see that this is index of 100. This is the true colors of a certain object. If the lighting is different and provide poor color rendering, then this is the shade of the colors that you will be seeing. You will not be seeing the true colors of the objects. So you can see here as well, we are comparing the color appearance under different lighting sources. This is a yellow light and this is a white light. So you can see that the colors are seen differently. So for offices, the color rendering index is required to be between 80 and 90. And this is easily achieved if we use the normal fluorescent lamps. Some other work environments would require higher values of the color rendering index. For example, medical examination rooms or operation rooms would require that this index between 90 and 100. Other industries, for example, industries that do the color mixing They require high indices as well. Printing industries would require that the lighting designer would require special attention to have accurate, very accurate color rendering. So you should know that different light sources would give different color rendering index. Another light source would be the mercury lamps, which have long life and produce around 50 lumens of light per watt of energy used, but the light produced is very weak in the yellow-red end of the light spectrum, and this makes it very difficult to perceive many colors under their light. Also, their efficiency drops with age, and many people find this light to be unpleasant. The metal halide lamps are more efficient than mercury lamps and have a longer rated life. These lamps tend to produce only about 50% of their rated output, and the color rendering is fair to moderate. On the other hand, the high pressure sodium lamps are very efficient and produce around 100 lumens or more of light per watt of energy used, and the life of the lamp can be around 5 years at average burning rates of 12 hours per day, but the color rendering is fair. The low pressure sodium lamps are the most efficient. It produces up to 190 lumens of light per watt of energy used, and the life of the lamp is ranging from 4 to 5 years at average burning rate of 12 hours per day. But its negative side is that the low pressure sodium lamps produce a yellow light, which is perceived to be unpleasant by many people, with very poor color rendering properties. You see that the reason for using lamps with poor color rendering would be their efficiency. As you can see with the low pressure and high pressure sodium lamps, which output more light per watt of electrical power than lamps that provide good color rendering. So each light source has its advantages and disadvantages, and it depends on the nature of the work environments. What is it? What's the type of activities being done? So to decide what is the best light source to be used at it. Also, there is the cost of the energy. You know that by switching to a more efficient light source, the energy saved can be very significant because lighting accounts for about 20 to 25% of the electricity consumed and up to 50% of electricity consumed in office environments. Many energy saving strategies has been proposed by Cook. Let's have a look at these strategies. The first strategy is to use more efficient lamps and fixtures and to have a better arrangement of these light fixtures using daylight, using sensors that turn lights off when they are not needed, on-off and dimmer switches so that people can turn off or reduce unneeded lighting, photoelectric sensors that sense the amount of daylight in the room and either switch lamps on or off or adjust the lamp brightness according to that, localized lighting in areas where more light is needed, reduced lighting levels in non-production areas, and regular cleaning of lamps and fixtures, windows, walls and ceilings, placing lights in better locations. So basically, these are the strategies that you need to be aware of regarding the lighting methods. Thank you.